Concurrency is a critical aspect of software development, especially in apps where performance and scalability are important. In this video, we will learn about concurrency in Go. Before starting, let's clarify the difference between concurrency and parallelism. Concurrency refers to the ability of a program to execute multiple tasks at the same time, while parallelism involves actually executing these tasks in parallel. If your machine has one CPU, your code will not run in parallel. So the concurrency is a design pattern that allows your code the potentially to run in parallel. At the basis of Go concurrency model are Goroutines. A Goroutine is a lightweight thread of execution managed by the Go runtime. Unlike traditional threads, which are managed by the operation system kernel, Goroutines are managed by Go runtime, making them more efficient and cheaper to create. Creating a Goroutine is as simple as prefixing a function call with a Go keyword. For example, let's see what we have here. We have two functions, say hi and say bye. Say hi printing in the terminal hi and say bye printing bye. We are starting from the main function, so if we run this application, we will get program starts, message in terminal. After we will call say hi function, which will print hi. Later say bye, which will print bye. At the end of the program, we will print program end. Let's do it in the terminal. Yeah, we can see the standard execution of this program. Now, if we want to run the function say hi as Goroutine, we need to just add the Go keyword before the function call. So I will write here Go and say hi. After running this program, we will see that we have a message program start, bye, and program end. Let's first understand why we don't see hi message. The program starts from main function, so first we have program start message in the terminal, and after say hi function is invoked as a Goroutine using the Go keyword, which means it will run concurrently with the rest of the program. Immediately after invoking say hi, say bye function is called. Later we have also print program end, and the main function reaches its end. And since there is no other blocking operation, the program is terminated. So the Go routine executing say hi may not have had a chance to run by the time the program terminates. So that's why hi is not printed. Now we will learn how to tell the app to wait until Goroutines will be finished. Waitgroup is actually a type of counter which blocks the execution of a function until its internal counter becomes 0. Let's see in the example. Let's create a variable wg. Let's create it globally. It's automatically imported sync package, which we needed. Before launching the Goroutine say hi, we are adding a 1. So we are writing wg. And we have here three functions, add, done, and wait. Here we have add, which is basically means that wait for one Goroutine. We have to add some blocker at the end of the program. Basically, wait will block the terminating of the program until internal counter will not be 0. Now, inside say hi function, we are calling done. And inside the say hi function, we are calling done, which is decrease the number of things that we are waiting for. So in this case, it will be 0 and the program will not be blocked anymore. If I will click to the done using control button, we will see that it's doing add -1, which is decreasing the internal counter. And what will we have here? So imagine we have a sum counter which equals to 0. Here we are adding 1, so we have 1 now. And wg wait will block the termination of the program until this counter will not be 0. We are creating say hi Goroutine, but our program is continuing to execute. And our say hi is still not finished. In the 27th line here, it's blocked. And it will be blocked until our code will not run wg done, which will decrease the internal counter with 1. And when the counter will be 0, our program will be terminated. Let's run the application and see the result. Now we can see that program starts, after we have a message bye, program ends, and later on we have a hi. The latest messages say hi. So the program waits until our Goroutine will be executed. We can also check the number of Goroutines that currently exist using the runtime package. Let's import first of all it. We can print one before say hi and one after. And let's print the same after calling say hi. At the first message we have Goroutines count is 1, and in second message we have 2 because we are creating a new Goroutine here. But why we have 1? Because the main function is also Goroutine. So we already have one Goroutine when we just started, and calling say hi we are creating the second Goroutine. Thank you for the watching. If you like this video, please subscribe to the channel.